everybody. I just wanted to spend just a very few minutes going over what melting point determination was and how it looks in the lab and what it's going to mean for Lab 2 and recrystallization. So just so you have an idea, the way that melting point determination is used is always to check the purity of solids. Solids have unique melting points, and we have pages and pages and pages and chapters and chapters and chapters of references of melting points of different solids. So what we can do is take a solid that we don't know, or an unknown, or a solid that may be impure, and we can compare it to the known melting point of that solid and see how impure it is. Or we can even make an identification or help make an identification based on that melting point. So we can say that if we have a solid that we purify using recrystallization and we get a melting point of something of it that's at 100 degrees Celsius, and that it could be the thing that has a melting point of 100 degrees Celsius or 120 degrees Celsius, we know that it's more likely going to be that compound at 100 degrees Celsius. The other thing that we can tell is that if we have a melting point and we come up with a melting point of 100 degrees Celsius, and the literature melting point is 101.2, we look up the melting point and we find that the melting point is 101.2, we can make some conclusions about how pure that solid is. That solid being 1 degree off is not necessarily that pure. Okay, so we can make some indications about the purity of solids based on that. The other thing to do is when we experimentally do melting point, we will always give it experimentally in a range. Now, literature values don't give melting points in ranges. They give melting points as just one number like this, okay? But a melting point in the lab will be given in a range. So we will always give it as, let's say, 101.1 to 101.5 degrees C. So that will be the range. This is the temperature that it starts melting. This is the temperature that it's done melting. Okay, and that's actually a pretty straightforward process for you to be able to do in the lab. When you look at a melting point apparatus, you can see right in there it's got a viewfinder that's similar to a microscope viewfinder or a microscope viewer, so you can see right into there and see the solid. A couple of things. If that range is too low, meaning it doesn't encompass the actual melting point of the solid, we can say that this is impure. We can say that there's probably some impurity. So here, if I'm looking at this range here that I just made up, and then this literature melting point, I would say that this range is fine because it encompasses the literature value. Okay, and so if we had this previous example where we had a melting point of 100 to 100.6, that does not include the literature value in its range, so therefore it would be impure. Now the other thing is this range should be pretty narrow. It shouldn't be too broad. If it is too broad, meaning it's more than 1 degree, that means that there's probably some solvent left in the solid and is causing this range to be broad. So it's possible to have, let me clear this off and make and do a different thing. So again, if we have our 101.2 literature value, if we come up with a range when we do our experiment of 101.2 to 101.7, Okay, let's say that that was our range that we got experimentally. Now notice that this is relatively pure because it does encompass the literature value, but notice that the range is broad. It's 1.5 degrees between the bottom and the top. This means that there's something in it causing the melting point to spread out, and typically that's a sign that there's solvent in there. Okay, so we can make two kind of conclusions about solids from melting point. We can determine if it's pure by looking if the range encompasses the literature value, and then we can determine if it's dry based on how broad the range is. So that's two pieces of information that's really important to get. The other thing that is important maybe from a real life standpoint is that it takes some time to do this. Okay, it's not slow like distillation is slow, but it's definitely not something that gets done over like a 3-minute period. It can take 10, 15, 20 minutes to get an accurate melting point, but the cost is very low. Okay, so that's good. It's effective. It's very effective. So here is what you get. Okay, here is an apparatus similar to what you will see right in the lab. And what you do is you put your solid in a tiny, tiny little test tube called a capillary tube. If a test tube looks like this, and it's going off the screen, a capillary tube is very thin, and so your solid will be piled in there. And that's so that we can melt it and not have a ton of crystals to melt, and so that it can melt evenly around the whole thing. Okay, and so what you're going to have to do is set a start point and end point. So again, if we're dealing with the substance that has a literature melting point of 101.2, then we should set that to 5 degrees on either side at least, so that we start the process at 96 degrees Celsius and go all the way up to 106 degrees Celsius, so that we're assured to encompass the melting process. Okay, and so what happens is this heats up. Okay, and so it starts at 96 degrees Celsius. It takes some time to get to that point, but then it'll beep and it'll be done. And then what's going to happen is this is going to heat up slowly, and we program the ramp. That's the speed at which it heats up. And so we probably want that to be around 1 degree Celsius per minute. So every 6 seconds, it's going up 1/10 of a degree. Okay, and so we want that to be slow, so that we can see so that we can actually get the temperature that it starts melting and the temperature that it's done melting. If we go too fast, the temperature is going to zoom up past the point that it melts, and it's not going to give you a good beginning or ending melting temperature, okay, because the temperature is going to rise too quickly. So if you keep it at about 1 degree a minute, this is going to help you determine an accurate range for your melting point. Okay, and so hopefully when you do this, you'll look through the little viewfinder, and you'll see that it actually looks like the end of this icicle kind of melting. You'll see a little bit of a liquid and a little bit of solid, and it'll look really it'll look pretty neat. It's actually one of the neater visuals in the organic lab when you're using some of the instrumentation. And so you get the temperature at which it starts melting, and then when it's finished melting, it's all just going to be liquid, and that will give you the range. So that's how we determine melting point in the lab using the melting point apparatus. And if you have any questions, feel free to reach out. Have a great day, everybody.